This is exercise 6.2a, question 9. We're told that line L has this equation here, negative 2, 1, 3 plus t times 4, 1p, and plane pi has the equation r dot 1, negative 1, 1 equals 10, or another way to write that is x minus y plus z equals 10. Given that L and pi intercept at the point B, which is 6, 3q, and then part A asks us to find the value of p, no problem. The arbitrary x, y, z points on this line is equal to negative 2 plus 4t, and then 1 plus t, and 3 plus pt. So when it intercepts with the plane pi, we can simply substitute in these values for x, y, and z. So we have negative 2 plus 4t minus 1 plus t, so minus 1 minus t, and then plus 3 plus 3t, so 3 plus pt, rather. So that should equal to 10. And of course we also have at this particular value where they do intercept. So for this particular value of t, we have that it's equal to 6, 3, and q. And so according to the first equation, we have negative 2 plus 4t is equal to 6. And so that must mean that t is equal to 2. Okay. So just adding all these numbers together, there's cancel. So we've got 3t plus pt, so that would be 6 plus 2p is equal to 10. And so from there we get that p is also equal to 2. And then that makes part B pretty easy because we have 3 plus p times t equals q. So 3 plus 2 times 2 equals q. And that is, of course, equal to 7. Moving on to part C now. We have that point A has coordinates 3, negative 6, 1. Show that A lies on pi. Not a problem. It just has to obey this equation here. So we have 3 minus negative 6 plus 1 equals 10. So that must mean that A is on pi. And then for part D, it says that points C and D are on L, such that the length of AC is equal to the length of AD is equal to 9. Find the coordinates of C and D. Not a problem. So if C and D are on L, then that means they have coordinates that look like this. So let's say so negative 2 plus 4c, 1 plus c, and 3 plus pc. We figured out that p was equal to 2. So 3 plus 2c. Alright, so that's our vector OC, where c is some real number here. And then so OD is the same. It's well, negative 2 plus 4d, 1 plus d, and 3 plus 2d. The point is we just have to find the possible values of c, and then alright, so the length of AC is equal to the length of AD is equal to 9. Alright, so first of all let's write down OA. So OA is equal to 3, negative 6, 1. Okay, so AC is the vector OC minus OA. So that will be negative 2 minus 3 gives us negative 5 plus 4c. And then 1 minus negative 6 would be 7 plus c. And then, wait, what am I doing? Yeah, 3 minus 1 would be 2. So 2 plus 2c. Okay, and we want to calculate the length of this thing. We're told that actually the length of it is 9. Okay, so then that means that the length of it squared is equal to 9 squared, which is 81. So that means that negative 5 plus 4c squared plus 7 plus c squared plus 2 plus 2c squared is equal to 81. And from here we're going to get a big long quadratic about c, and we'll just find the possible values that c can take. Okay, so 16c squared minus 40c plus 25 plus c squared plus 14c plus 49 plus 4c squared plus 8c plus 4 equals 81. So we have 17c squared, so 21c squared in total. Okay, how many c's do we have? Minus 40 plus 14 plus 8. So that will be minus 40 plus 22. So that will be minus 18c. Then how many constants? 25 plus 49 makes 74, plus 4 makes 78, and that's equal to 81. So 78 minus 81 will be minus 3 equals 0. And then you can solve that equation on the calculator or use quadratic formula if you like. I'm going to use my calculator. So 21, negative 18, and negative 3. And we get that c is equal to 1 or negative 1 over 7. Then, of course, that is going to be our d vector. And so if I write it out, again, it's so OC is equal to, I forgot already, negative 2 plus 4c and 1 plus c, and then the last one was 3 plus 2c. Okay, and then putting in c equals 1, we get negative 2 plus 4 makes 2, 1 plus 1 makes 2, and 3 plus 2 times 2 makes 7. So that is our, wait, did I say 7? That was pretty dumb. It's of course not 7. C is equal to 1 here, so that would be 3 plus 2 makes 5. Okay, silly me, silly me. Alright, let's do the D1 now. So OD, okay, this time we're putting in C equals negative 1 over 7. So it'll be negative 2 minus 4 over 7. So that would be negative 18 over 7. And then we have 1 minus 1 over 7. That one's easy, is 6 over 7. And then 3 minus 2 over 7. So that would be 21 over 7 minus 2 over 7. So that would be 19 over 7. And of course, another way to write that would be 1 over 7 times the vector negative 18, 6, and 19. Okay, and that is all for this question.